Alright, so hello everyone. Welcome to Impulse Batch Doubt Solving Session Physics. Today I'm going to take the doubts of the chapter Electromagnetic Induction. In this session I'm going to take total 12 doubts. First 4 on your screen. The next 4, out of which the question number 12. So you see I have given a star because it is a conceptually important question. Alright, and the next 4. So let's begin. What's the question? A coil is wound on a frame of rectangular cross section. If the linear dimensions of frame are doubled and number of turns per unit length of the coil remains the same, then the self-inductance increases by a factor. Alright, so you guys might be knowing E is equal to L di by dt, right? But from this equation we cannot comment whether L is proportional to how is L related basically to number of turns per unit length and other dimensions. So we have a formula of L which is actually L is equal to n square nu 0 nu r, that is relative permeability, into area upon length. This is the basic formula which relates self-inductance with number of turns, relative permeability, area and its length. So I won't much derive from where that formula came, but I can tell you that self-inductance is basically n square upon S. S is reluctance and we write S as L upon UA. So maybe it might not be in your portion, but alright. Is it clear? L equal to n square nu 0 nu r A upon L. So what the question is saying is we have to find by how much L increases if the given conditions are satisfied. So given condition is number of turns per unit length is constant, right? Alright, here we have n square, so basically a constant number, and if I square it, alright, constant square, so basically constant square is also a constant. So I'll try to make n upon L whole square here. I have n square, but in denominator I have only L. So what I do is I multiply and divide by L. Nu 0 nu r, I write nu 0 nu r as nu into A. Alright, so now is it okay? See, n square, LL will get cancelled. Basically these both terms are the same. But why I did this? Because n upon L whole square, n upon L is given as constant, right? See, number of turns per unit length of the coil remains same. That's why I write it. So n upon L whole square is constant. We all know nu is constant. So what's remaining? A and L. So we can comment that L, that is self-inductance, is directly proportional to area into length. You get that? Alright. But see, there is a coil. Say for example it has a radius r and length L. So its area is basically, if it's a circular coil, it's r square. So it's directly proportional to square of the radius, right? And they are telling that the dimensions are doubled. It means radius is doubled, length is doubled, right? If radius is doubled, area is made 4 times, right? Pi into 4r square. You get that? So if radius is doubled, area will become 4 times. Now area is 4 times and length, as we all know, is doubled. So the total factor by which the self-inductance will change, L dash we can call it as, it will be 8 times L, right? So the answer for this question is C, option number C, which is 8 times the initial value. So this is the basic formula of self-inductance. Alright, so let's go to the next question. A magnet north-south is suspended from a spring and which it oscillates, and while it oscillates the magnet moves in and out of the coil C. The coil C is connected to galvanometer. The magnet then, as the magnet oscillates, which of the following options is true? Alright, so for simplicity, let's initially consider this magnet is fully compressed, alright, north and south, and we don't have any galvanometer or any stuff here. Alright, so it will perform SHM, right? How will it go? It is basically at t equal to 0, let's assume it. It has angular velocity omega, velocity linear velocity v, time period t. Alright, so it is at time period t equal to 0 seconds. So after some time, the compression will be a bit less, and it will reach somewhat here. Say this is the midpoint of its total path. So you all know, you can compare it with basic SHM system, right? Here we have a block, and it then goes from amplitude 0 to A, and then again it goes from A to 2A, then again it's go from 2A to A, and then to initial position. So here we are going to consider that case. So at this point it is at A, and due to self weight more, due to it will gain some velocity. Here it will be maximum, right? V is equal to A omega. Here V is 0, and after somewhere it will go down and reach the maximum it can reach. Maximum point at where it can reach, it is basically distance from this point, it's 2A. We don't write here. At this point velocity becomes 0, and it again starts going back towards the center and again to its initial position. Well, this is ideal condition. Alright, but now things are not ideal. We have introduced galvanometer there, and a coil is also present, right? So, and we have magnets. Means we have magnetic field, and we have a coil. So you all know. Now consider second condition. If we bring, this is ideal condition, right? Now non-ideal case, that is what will happen in this condition according to the question. So we have the magnet north south. Initially nothing will change because we haven't yet brought it towards the coil, but when we bring it towards the coil, right, clearly it will have some velocity, right? And so due to velocity, we all know EMF will be induced, flux will be changed, EMF will be induced, right? Now, so if EMF is induced, so current will also be induced. You're getting that? So galvanometer will basically show some deflection. So clearly here option A states that galvanometer will show deflection to left and right, but amplitude steadily decreases. Alright, we have no comment on it. But option B, it can easily be eliminated, which states G shows no deflection. It must show deflection, alright, because EMF is induced, then current will get induced. Alright, so here we have. So now what will happen? Clearly the most important concept here, it goes Lenz's law. You all know. All what it wants is it opposes basically change in flux. It doesn't want any change in flux. Alright, but now as we have introduced field here, flux is changed. So what will it try? See, the system is going down. Alright, we are at, suppose at amplitude A, the system is going down, so it will get opposed. Alright, due to Lenz's law, it will face an opposition. The field, the magnet will face an opposition towards upwards. Alright, so what will happen? See, in ideal condition it went very well till down, and again it went in initial position. But now, so for example, this is x equal to 0 in ideal case. As I told, it will exactly go down and complete amplitude 2A in ideal case. Alright, but in this case it can't. Its velocity will basically become 0 at a point which will be less than 2A. Suppose at a distance x, you're getting that. It will basically, it means that its amplitude is getting reduced, because it is getting opposed. That is what Lenz's law states. Alright, so now, okay, it got opposed, it reached down, finally its velocity became 0. So now it will again go up, alright, which will again produce change in flux. So basically current is induced in, suppose, this direction, right direction in first case. Now it is going upwards. Even though it is going upwards, it will again face change, it will again get opposed basically, right? But this time the direction of current will get exactly opposite. You're getting that? We have the coil here. Initially it was going down, EMF was induced, therefore current was induced, opposition was faced which was upwards. But now the coil, the magnet is itself going up, so of course it will face, of course again EMF will be induced, again current will be induced, but this time in opposite direction, and it will also face resistance in downward direction. Basically what Lenz's law states, it doesn't want any change in flux, it wants the system to be in equilibrium. Exactly right. As soon as the velocity becomes zero, there will be no EMF induced, there will be no change in flux, there will be no current induced. So this is what the question states. So basically we clearly saw that the amplitude is getting decreased due to opposition. Alright, and also galvanometer initially, if it was in deflecting towards right while going down, while the magnet was going down, so while the magnet was going up, it just direction got exactly opposite. Current was induced in both cases. So what we can comment is amplitude is not constant, it is decreasing, steadily decreasing, and the galvanometer shows deflection towards right and left. So option number A is, I guess, matching. Galvanometer shows no deflection to left and right, but amplitude steadily decreases. The important point is amplitude steadily decreases. Energy dissipation is an important concept here. What will happen? Energy will get dissipated, and so amplitude will slowly reduce, and it will become zero, and the system will be stable after some time. Alright, you get it? So question number 2, we have the answer option number A. Alright, so next question. A metallic ring. Alright, let's consider this is a ring given. Alright, this is a metallic ring and it's connected to a rod which oscillates freely like a pendulum, and we have given a magnetic field here. Alright, so what is asked? If magnetic field is applied in horizontal direction so that the pendulum now swings through the field, the pendulum will, which of the 4 options is correct? Alright, it is quite similar to the previous problem. As I stated before, this is a metallic ring, suppose it has resistance R. Alright, so now when it will come in contact with this field, we have B. We have some velocity with which this coil will come. So basically, flux will get changed, EMF will be induced. Alright, and so according to Lenz's law, again this ring will face some opposition, maybe in the form of energy dissipation. So if the coil, the ring which is basically moving like this, initially it was here, then it went here, and it's oscillating, right? So basically during this process, as there is a field present here, due to Lenz's law, it will face opposition in form of energy dissipation. So basically what will happen is, you all keep in mind this, energy dissipation, basically it means energy of the system here is getting reduced. So suppose it has some kinetic energy and potential energy, that is total energy. Total energy is getting reduced and it's converted into the energy in form stored in the field. Alright, so what will happen? Slowly its amplitude will get decreased like in previous problem. Slowly it will move left, right, and slowly it will come to the rest very soon. Why? Because it is getting opposed by the field here. Due to Lenz's law, energy will get dissipated and it will come to rest. So I think option number E is matching. Come to rest very soon. Yeah. So basic reason behind this question, basic hint we can say, is energy dissipation due to change in flux. Alright. So next question. The ratio of secondary to primary turns in transformers. So secondary turns will be denoted by N2 and primary turns will be denoted by N1 is given 3:2. Alright. If power output. Alright. Power output. What is power? It's voltage into current. Alright. So output means I denoted by V2 and I2, right? So power output we have as V2 I2. Alright, and what is asked in the question? Okay, so what's asked in the question is, if the power output be P, then the input power is. So basically we have been asked input power, but we have given that neglecting all losses. So basically I don't think we need to solve this question, as there is no losses, right? What it means that initial power input is basically power output. Yeah, no losses states power input is power output. So maybe some of you might be solving like this, so you all might do like this: n2 upon n1 is equal to v2 upon v1, and we all know it is reciprocal in case of current, i1 upon I2. Alright, we can go by this also, but see, it is given 3 by 2. So I cross multiply. So it's I2 into V2 is I1 into V1. See here, by these two conditions. And I guess I2 into V2 is power output, and I1 into V1 is power input. And also it is given that we are neglecting all losses. So basically this itself is P, and so answer of this question is also P. Power input is power output. So don't get confused. This data is given in question to confuse you. Like some of you might think like 3 by 2, so it's 1.5 times P, and mark the option number B. So it's not like that. You have to basically focus on the concept. Power input is power output. Power is what? Voltage into current. Final voltage into final current is equal to initial voltage into initial current, and there is no loss. If there would have been loss, so we would have then checked efficiency. Efficiency would have been given, and we would have used the formula efficiency is equal to power output upon power input. Coefficient, this is basically coefficient of efficiency. So but in this case, when there are no losses, efficiency becomes 1 and power input becomes power output. Alright, it's clear. So option number C is the correct answer. It's P only. Alright, so alright, so what's the next question? A given wire is bent into a circular loop of radius 7 cm. Okay, given wire, alright, it's a circle, is bent into a loop of radius 7 cm and is placed perpendicular to a magnetic field. We have given the value of B, which is 1 Tesla, within 0.1 second, that is delta T is 0.1. The loop is changed to, okay, so this question is a bit wrong. It's not 100 centimeter square, it's the area which is given, A2. Fine, afterward the area which gets converted is 100 centimeters square. So that may be the doubt of a student because of the error in the question, but A2 is given, which is equal to 100 centimeters square. Alright, so what's asked, and here the field is B2, we call it as this B1, and B2 is 1.8 Tesla, right? Alright, so EMF induced is asked. So EMF induced is what? Delta phi by delta T, right? And 5 is BA, but it's delta BA. Therefore we can write it as B2A2 minus B1A1 upon delta T. So just we have to now substitute the values. B2 is, we have 1.8 and A2 is 100 centimeter square. I'll keep it in centimeter square, later I'll convert in meters. Alright, so yeah, minus, what's B1? It's 1. And what's initial area? It's a circle, so it will be pi and r square, that is 7 square, whole upon, what's delta T? It's 0.1. Alright, yeah, so what's 1.8 into 100? It's 180 minus 7 square, 49 pi, alright, upon 0.1. What will be the unit? C. For B it's Tesla, and I have considered the area in centimeters square, and time will be, of course, seconds, T. Yeah, this will be the unit. So now I have to calculate the value of 49 pi. 49 pi, so pi is like 3.14. So 9 fours are 36, 3 carry over, 4 fours are 16, 196 we have here, 9 and a 4, and now 3 nines are 27, 214. Alright, so we'll get the addition as, it's like 150, I guess. Yeah, 153.86. So I don't want it in decimals, so I'll approximate it to 154. So it will become 180 minus 154 upon 0.1 Tesla centimeter square per second. So upon 0.1 is 180 minus 154, it's 26, and upon 0.1 it's like into 10, so it will be 260 Tesla centimeter square per second. Now Tesla is the SI unit, second is the SI unit, all I need is centimeter square to convert into meter square, so I'll multiply it by 10 raised to minus 4, so it will become 26 into 10 raised to minus 3, which is 26 millivolts. Alright, so the option matching this question answer is option number B, 26 millivolts. Alright, so let's move to the next question. When the number of turns in the coil is doubled without any change in length of the coil, it's self-inductance. Alright, I guess the first question which I told you is L is equal to N square nu 0 nu R into A by L. Alright, so what's given in the question? Number of turns is doubled, so basically N square will be 4 times, and without change in length, so basically nu 0 nu R, area, length, all these are constant. So self-inductance clearly will become 4 times, as L is directly proportional to N square. So option number A. Okay, so you have to learn this formula, and for its derivation it's a bit lengthy because you have to go through some concepts which maybe are not in your syllabus, like reluctance, etc. So just learn this formula, it's important, self-inductance. So let's move on to the next question. The figure shows a square loop of side 0.5 meter and resistance 10 ohms. The magnetic field has a magnitude B is equal to 1 Tesla. The work done in pulling the loop out of the field slowly and uniformly in 2 seconds is. Alright, so work done. So firstly, what we get clicked after the term we hear work done is that work done is F dot dx, right? F dot dx. Alright, so we know that F is basically in magnetism, it's ILB sine theta. Yeah, of course, it's ILB sine theta into dx. Let's call it here dx. What is the question? Work done in pulling out the the loop. So we have this loop of which we have, let's assume it has side L, which is given already, it's 0.5 meters. It's a square, so every side is same 0.5 meters. So basically we have to cover this distance to pull it out there, so dx will become 0.5 meters, half meter, that is. Alright, and now sine theta. What is theta? Basically it is basically I into L cross B, angle between length vector and the field vector. So clearly field is cross means inward. Okay, so field is inwards, we have the length here, it's into the plane, so basically the angle is 90 degree, right? Length is here and we have field inside. Okay, so angle is 90 degree here, it is theta, so sine 90 is 1, so we have ILB into dx, which is half. That's the work done. But we don't have current given in the question, but we know current is voltage upon resistance, and that's why resistance is given in this question, into length, which is again half, into the field, which is 1 Tesla, I guess, yeah, into half. So now we have to calculate V in voltage, it's basically EMF. And what's the formula of EMF? You all know it's BLB. But again, we don't have velocity here, but we know velocity is distance upon time, and distance we have to cover dx, which is half a meter, so it will be like BL and half. And what is time? It's again 2 seconds. So it's BL by 4. We can replace this voltage BL by 4. And what's the resistance given in the question? It's C, 10 ohms. So we just substitute all the values. Half into half, it becomes 1 by 4. And so B, we have the value 1. Length, again we have it's 0.5, that is 1 upon 2 into 4 into 10. And this also we have 4. So all this, so see, we have options in 10 raised to minus form. So we just need to calculate. The unit will be joules now. So for simplification, see, we know 1 upon 2 into 4, it's 1 upon 8. Alright, 1 upon 8, it's 0.125, right? And so 0.125, and we have in the denominator 10 into 4. Alright, sorry, we have 0.125 upon, I took this 1 upon 8, which is 0.125 upon 4 into 10. We don't have issue about this 10. We can write it 0.0125 upon 4. Now see, we don't need to calculate this, we just see, check the options. See, so what we have to do is 125 by 4 basically. So it's like 3 is at 12 and it's gone, it's 5. So it's like 3, 1, 4. So what we get is 3, 1 point. Now here we get 1 and 0 and we get 2. So basically what option is matching is 3.125. Right, we get 2 is remaining and then 0 will remain and will get 5. So it will be 3.125. And decimals would automatically get adjusted as there is no other option which is matching. So option number A is the correct option for this question. So what you need to understand in this question is the transformations we have done. We have written F as ILB sine theta, and we have considered dx. We have to pull the loop, so the distance we have to cover is half a meter. And then I wrote current as voltage upon resistance. Alright, and so I also didn't know the voltage, so I write it by the formula EMF is BLV. Now again I don't know the velocity, so but I know that time is given, and so I have to use it. Maybe it's a hint here, so I write velocity as distance upon time, and then just calculations are required. So option number A is the correct answer for this question. So let's move on to the next question. Alright, I've marked here important conceptual question. So for Mhtcet also this question is important, and as a concept also this question is important. So what this question states is a magnet is dropped down an infinitely long vertical tube, then which of the following 4 options is correct? Alright, so we have an infinitely long vertical tube. Alright, and we have a magnet dropped. It has north south. Alright, so we have a magnet dropped maybe like this in such a manner or in the perpendicular manner, north south. Alright, so what the question is, if we drop a magnet, it will gain some velocity v, which will be continuously changing. Right, like you can imagine if this is a building and you put a ball down from here, it's not like it has initial velocity, basically v is equal to 0, then it gains velocity due to acceleration, and it means velocity basically is changing. All what I want to convey is the velocity is changing. Alright, so now it's a copper tube, right? It's a copper tube and we have a magnet. What does it imply? We have conducting material, we have a field, so basically flux will get changed, and so basically EMF will be induced. All I want to tell you is EMF will be induced, right, due to change in flux. Why? Because it's BLV, you all know that. Why the flux is changing? Because the velocity is continuously changing. You get that velocity here is not constant, it's changing. So flux will continuously keep on changing, and so EMF will be induced. So what will happen? Initially, it was up having velocity, some velocity. Now, as we have dropped it, and it's infinite long. So it's not like it has gone, it came out of it and then some condition. It's an infinitely long vertical copper tube. So we have to consider it will remain in this, and we have to consider this condition. So what will happen is basically when it comes into somewhat, sometimes say it is in the center, or it's like, okay, it's in the middle of this tube, north and south, it's gaining velocity, right? So as the EMF is induced, again an important concept, like I told in previous question, Lenz's law. What it wants is there should be no change in flux, and if there is a change in flux, opposition will take place in many forms. Maybe this time eddy currents may get induced. Basically what will happen, it's going down with increasing velocity, it will get opposed due to Lenz's law. As there is a change in flux, EMF will be induced. According to Lenz's law, it will get opposed. Eddy currents will be developed here in opposite direction, which will try to decrease this velocity. Alright, so now initially, as we have put it down, also due to gravity, it has some acceleration. So its velocity is increasing as it is going down, and so it is facing opposition by the Lenz's law. So what will happen at a certain period of time? At a certain period of time, it will reach its velocity maximum, Vmax. Still we have from the initial point, opposition is like increasing slowly, but when the velocity here will become maximum, alright, the opposition will also become such that opposition will slowly increase. Initially, suppose it is not that much that it could stop the complete acceleration, but slowly opposition increases, and it increases to that extent that it cancels the acceleration. So by G, suppose by force mg it's going down. It's not like mg, but just I'm giving an example. So an opposition force that is equivalent to mg will be act. So basically what will happen, its acceleration will get stopped. Meaning, so it does not mean that magnet will get stationary there. No, its acceleration has stopped. Means now it will acquire a velocity which is constant. You get that? And that constant velocity is termed as terminal velocity. So basically, to summarize, the magnet came down and it had acceleration as well as velocity due to change in velocity. Basically, what is acceleration? What's acceleration? Is dv by dt, change in velocity with respect to time, right? Its velocity was continuously increasing, acceleration was there, and slowly due to Lenz's law, an opposition was developed which was trying to counter, which was trying that the change in flux must become zero as soon as possible. Alright, so slowly the opposition force started increasing, and it let the magnet reach a velocity Vmax, and at that instant itself the opposition force was also maximum. Now see, you will say that after opposition maximum, it cancelled the it's like acceleration. So why, you all might think that it will now exert force upwards, but it's not so, because velocities finally became constant, and you see PLV is became constant. So basically change in flux will be zero. That's all we want, right? That's what Lenz's law stated. Change in flux must be zero. If initially it had constant velocity BLV, we had no problem with it, but since it had acceleration, an opposition force was developed which encountered the acceleration, and after that the magnet had some velocity V which it continuously went down and down infinitely. So basically the option which matches to this question is option number D, which is important concept, the concept of terminal velocity. The magnet moves continuously with increasing velocity and ultimately acquires a constant velocity. See, as I told you, it had initial acceleration, so its velocity was increasing, but then the acceleration got countered due to opposition, and then it had a velocity v, because of which the flux became constant, dlv became constant, emf induced became constant. EMF was not induced basically, since flux was constant. BLV is the formula of EMF induced. Since V is constant, so EMF induced it's BL delta V, but delta V is 0, EMF induced is 0, and so now it will move with the constant velocity, which is termed as terminal velocity. So that's an important concept which I wanted to tell you all. So option which matches to this question is option number D. Alright, so let's move to the next question. Alright, so what it states: a circular coil of diameter 21 cm is placed in a magnetic field of induction 10 raised to minus 4 Tesla. The magnitude of flux linked with coil when the plane makes an angle 30 degree with the field. Alright, so we have to calculate the magnitude of flux, and we all know flux is BA cos theta. But what students do, general mistake, they don't completely understand the term theta. Theta is the angle between the area vector and the field. And what does area vector means? Suppose we have a circular coil here. We consider this circular coil. So it's not like along parallel to this coil the area vector. Area vector is always perpendicular to the coil. Always remember, area vector is perpendicular to the coil. But what is given in the question? Plane of the coil. This is the plane of the coil. It makes an angle 30 degree with the field. Alright, so maybe the field is somewhat here, this is plane, and field is somewhat here, making angle somewhat inclined 30 degrees, right? But so is it that we have to put cos 30 degrees? Absolutely no. Phi is equal to BA cos theta. It means we have, what is theta? We have to calculate theta. We have the area vector upwards, which is at 90 degree, right? We have the plane here, and at 30 degrees we have the field. 30 degrees we have the field. So what's this angle? It's 90 minus 30, which is 60 degrees. So basically as theta is 60 degrees, the angle between the area vector, like this is the area vector and the field, it's now 60 degrees. And this angle was given in the question 30 degrees. So what generally people do, or students make mistake, it's they like phi is equal to BA cos 30 degree, which is completely wrong. We have to use phi is equal to BA cos 60 degrees. You got the basic concept. What theta is basically is important in this question. Else is calculation remaining. So what's B given? It's 10 raised to minus 4. And what's the area? It's like diameter is given, so it's pi d square by 4. And what's cos 60? It's half. So the rest is just the calculation. Pi we have 3.14 into d square, it's 21 into 21 into, it is in centimeters, right? So it's 10 raised to minus 4 whole upon 4 into 2, it's 8. Alright, so all we have to do is now just basic calculations. We got in the denominator 4 into 2, which is 8. Alright, so 21 square we all know is 441, and into we have like 3.14 by 8. Alright, so now let's just think, how can we solve, how can we approximate basically this question? So we have 10 raised to minus 4 here, right? 10 raised to minus 4 is here. I can consider this 441 as 440, and I can divide it by, like, I can divide it by 4, it will be like 110, it will be like 2 ones are, it will be like somewhat 55, and so it's like 55 into 3.14. We know 55 into 3, it's like 150, and due to this some error the answer might go till 165, 170 approx, right? So it will be like, calculation will be like 170 approx, right, into 10 raised to minus 4. So after shifting decimals, it's like 1.7 something into 10 raised to minus 6. And I think there is no option which is even close to 1.7 or 1.6, whatever. So I think option B, because it's 4.2, it's 3.1, it's 1.44. Yeah, they are a bit close, but 1.6 or 1.7, as we have approximated, we have made it 440 and then just multiplied 55 into 3.14, and just basically we did approximations here, right? So the, yeah, on calculator as well you can do it. 55 into 3.14, it will result in like somewhat 172.7. So option is, correct option for this question is option number B, 1.732 into 10 raised to power minus 6 Webers. The unit of, maybe yes, the unit of flux, it's Webers. So let's move to the next question. A circular disc. Okay, so again maybe, yeah, maybe it's a similar type of question. Circular disc of radius we have given 0.2 meters is placed in uniform magnetic field. It's 1 upon pi Weber per meter square. Alright, in such a way that its axis make angle 60 degree with B. Alright, so now question is basically, now you see we have to calculate flux BA cos theta. Now we can put theta as 60 degrees. Why? Its axis, see, the axis always passes through the center. We have this axis of the disk, right? Its axis is basically the area vector, and the angle it makes with B, it's given as 60 degree, which is appropriate, which is correct. So we can substitute here theta is equal to 60 degree, and so our flux phi will become B, which is 1 upon pi into area. It's like pi into 0.2, yeah, 0.2 into 0.2 r square into cos 60 degrees. So pi and pi will get cancelled, so we have 0.2 into 0.2 into its 1 by 2 cos 60. So it's like 1's a 0.1's a, so it's 0.2 into 0.1 is 0.02 Webers. Yeah, clear. So option number A is the right answer for this question. In this question directly, since the word axis was mentioned, we knew that this is the axis, which is the area vector, which is basically perpendicular to it, and its angle directly with the magnetic field was given, which is theta. So answer for this question is option number A. Alright, so let's move to the next question. What it states, it's a bit blur, I guess, so for you all guys, let me zoom. Okay, let it be, I'll read it for you. A straight horizontal conducting rod, a straight horizontal conducting rod of length L and mass M is suspended. Alright, so the question is, a straight horizontal conducting rod of length L and mass M is suspended by two vertical wires at its ends. If I is the current passing through the rod, then in order the tension in the wire is 0, in order that the tension in the wire is 0, the magnetic field set up to the normal to the conductor. Alright, so we have a bit, I guess it was the question asked in Mhtcet 2020. Yeah, I guess. So basically tension in the wire is 0 is asked. Horizontal conducting rod, so let's assume it's horizontal conducting rod is of length L, mass M, is suspended by two vertical wires at its end. Alright, so we have two vertical wires, it is suspended here. Then in order tension in the wire is 0. Alright, tension in the wire is 0. So basically some tension is developed in it due to its weight, which is acting, right, mg. Magnetic field setup normal to the conductor is, so we have to calculate the magnetic field, that is B, in order that the tension here it becomes 0. Now it's such a simple question. See, let's consider the FBD, free body diagram. This is suppose the center of mass from which the weight mg is acting, and what we have been told that of course we know that tension is developed, but tension developed is 0, so there must be some other force, right, which must balance this mg. That's the basic condition in the question. So we have to equate mg in terms of magnetic field, like magnetic field, current and length. We all know the force is IBL sine theta, which is BIL. Clear? So the weight mg, which is acting downwards, should be, tension is 0. As the tension is 0, there must be some force, and that force is nothing but this ILP force. So clearly we can find out the value of B. It will be mg by IL. No doubt in this question. Option number D must match. And yeah, it was a pretty simple question, but we just had to imagine things, that when tension 0, there must be force which might be acting due to the field, right, due to the field in opposite direction, that is ILB. Yeah, so answer of this question is option number D. It's not option number B, it's B bar, it's magnetic induction. So yeah, answer is option number D for this question, mg by IL. Next question. Yeah, so this question is basically a graphical question. Let me clearly show for you all. This graph, it's I, it's time t. So this, it has some nature like this, and it is extended here till t by 4, t by 2, 3t by 4, and this is maybe somewhat t afterwards. Alright, what is asked? Induced EMF. Induced EMF is asked. So we all know, according to Lenz's law and the equation of E is minus n d phi by dt. In graphical questions, no, we have to consider this minus sign as well, because maybe sometimes the answer goes in negative quadrant, so this minus sign is also very important, and which is basically a consequence of the Lenz's law, right? So yeah, let's calculate d phi by dt. Okay, EMF induced is d phi by dt, but I don't think this d phi by dt will help. I have current and I have time, so which equation is related with current, time and EMF? I guess it is E is equal to L di by dt, isn't it? Maybe this equation might help me, as di by dt is basically y by x, that is the slope of this curve is di. Maybe it will give me di by dt. And what is asked? The variation of induced EMF. See, in all four options, EMF variation is asked according to time again. So now consider here, from t is equal to 0 to t is equal to t by 4, we have slope here, right? So now again we have, if we consider here Lenz's law, it will be E is minus L di by dt. Since E is minus n d phi by dt, it's also E is minus L di by dt. I forgot the sign, which is important in this case. So see, suppose we have slope from t is equal to 0 to t is equal to t by 4. What will the slope? It's a fixed value. Can you see that at least? And it's have a positive slope. Suppose it has positive slope plus k, right? So what will be EMF induced? It will be L into plus k. Let us call it as some constant c. So basically what we get is EMF is a constant, right, but it's minus L, it's minus c. So basically EMF induced from t is equal to 0 to t is equal to t by 4 is a negative constant, means it is negative. EMF induced, alright, it is negative and it is constant. So first we have this. Now see clearly, this is a line parallel to x-axis, so its slope is 0, right? So clearly EMF induced will also be 0. So we have a sudden drop of EMF which suddenly dropped to 0, isn't it? This, at this point EMF is 0 till certain time. Till how much time? From t is equal to t by 4 to t by 2, t by 4 to to t by 2 continuously. We have the EMF 0. Now the slope became negative, so basically di by dt has become minus a constant. So EMF induced, this will be minus L into minus K, which will be positive constant. So we will go somewhat above here and it will be some constant. So we are getting this type of structure, and I guess yes, option D is the perfect option which is matching, since afterwards again it is become 0, so it will drop again. Yeah, so clearly this, see, this structure, this option is matching. So option number D. So what we have to, and what people or students do is they consider option number C, and there is nothing wrong in their maybe interpretation, but this minus sign, this opposition, that Lenz's law, again I am telling, very important point, Lenz's law, we can't ignore in case of graphical questions. Since your quadrant changes, and so here option C and option D, clearly some of you may mark option C, which is wrong, because you have to consider the minus sign, which is opposition due to change in flux. That is the Lenz's law. Alright, so option number D is right answer for this question. Alright, so let's move. Oh, it's done. Alright, so we had total